This is electronics and robotics in a nutshell. A lot of people wish there was a way to learn electronics and robotics in one 5-minute video. The truth is, that is impossible. The good news is, you can think you understand it all in a 5-minute video. Looking at it all on the most basic level, what is going on? We have some components, they're connected together, a source of electricity is supplied, and the components perform work. Maybe in the form of LEDs turning on and off, servo motors rotating, or DC motors spinning up. Whatever work is being performed, understand that nothing is going to happen unless a source of current is flowing, just like running water. That current is flowing at a rate which we label as amperes. The pressure behind that flow is called the voltage. Both of these can kill you, despite what you may have heard. But you don't have to worry about that when you're first starting out. Now, let's go over the essential basic components. Batteries, the power source. They store the voltage and current required to power your build. Resistors, resist. They restrict the flow of electricity to protect components, like LEDs, from too much current. Capacitors. Think of these as small batteries that fill up with electricity, which comes from the power source, and they discharge immediately after they are filled. This sends the electricity on their way again. What do? For one, they can help smooth out dips in the flow of electricity, which we call brownouts. They help supply a more constant, predictable flow from the power source. They fill up and discharge so fast, it appears as a constant supply, so you don't have to worry. Be careful though. Some are extremely dangerous. If you go touching them, they can turn you into fried chicken. Diodes are like a one-way street, like a nozzle for a water hose. They only let the current flow in one direction. These are useful when you don't want any current to flow backwards, such as when you stop a powering motor and the electromagnetic field collapses. This can send current in the opposite direction, potentially damaging other components. Think of like when you're spraying some sort of spray and you decide to light it with a lighter and create a flamethrower. Well, some people, that flame travels back in through the nozzle and can explode the tank that they're holding in their hand. So a diode prevents that from happening. LED stands for light emitting diode. It is a semiconductor light source, and when the current flows through it, it emits light. There's an anode and a cathode, basically a positive and a negative side. When the current flows through it, the electrons in the positive and negative side go through electron holes in the middle. When they fuse together, they emit light. Sounds kind of like a small-scale nuclear fusion to me. Transistors. This is the foundation of all modern electronics, arguably. There are many flavors of transistors, kind of like a Baskin-Robbins. They can be doped negatively or positively. Basically, they act as gates that control the flow of current by introducing or stopping a very small current to the gate pin. Like I said, there are many different kinds. Scientists don't even agree exactly what's going on in there, and some say it was aliens. Also, you can double up transistors to handle double the current. They share the load evenly. Awesome! Just know about it for now. The one that you're going to want to use as a beginner are the NPN, negative, positive, negative, doped, metal oxide field effect transistors, or MOSFET for short. NPN MOSFETs, they're very cheap, and they are exactly what you need. You're just using them as a gate. When you want to drive some serious current, you will want some power MOSFETs. For now, just focus on NPN MOSFETs. Push buttons allow for current to flow through, or they stop current from flowing through. They are very simple. They can be hard or soft. You have many options here. Potentiometers are also known as variable resistors. They are just resistors that can change the amount of current being resisted by sliding a conductive material across non-conductive material. This is what happens when you twist. They usually have about 3 pins, voltage in, voltage out, and the actual output voltage which you are creating by your twisting motion. Motors. Motors also come in many varieties. Some handle DC current, some handle AC current. They usually consist of coils of wire which rotate around magnets when the electricity flows through those coils, or the other way around. There are many different types for different reasons. When working with basic electronics and robotics, you will start out using low torque, high RPM DC motors. You can increase torque by hooking up gears to translate speed into torque. Again, it's like a Baskin-Robbins. There are many, many options. For now, just learn about the low voltage DC motors. They're very cheap. Get a few dozen. Servos, a type of motor that turns clockwise or counterclockwise. Depending on the length of time a current of electricity comes into it. There are generally 3 wires for, guess what? Voltage in, voltage out, and signal voltage in. These operate at certain frequencies, so you will need to supply the signal current to it with a microcontroller. In the microcontroller, you set up the frequency and the pulses which will be sent to the servo. The time period which these pulses need to be sent in order to control it, to turn it left and right, are very, very short. The durations are very short. Hence, you need something very fast, like a microcontroller, which can turn on the voltage and turn off the voltage very quickly for you. Imagine trying to do that by hand. Come on. The last most basic, essential component are microcontrollers. These are also known as tiny computers. They have millions to billions of transistors inside. Remember, transistors are just switches, gates, being turned on and off really fast. Guess what you do with the microchip? You program them to flip these switches on or off. With these, you can create timers, convert analog and digital signals, perform calculations, communicate with sensors or other computers, set up interrupts, which are like gun triggers that go off with conditions you set up, and so much more. They are everywhere and in everything. Even a $1 microcontroller can power a robot or potentially communicate with satellites in space. So have some respect. There are many other components which I recommend and don't recommend, but this is enough to get your imagination going. When testing your concepts, you can use a breadboard, which allows you to temporarily punch in the wires and components and move them around however you like and try things out. Once you get a good layout, you can finalize your project by soldering it to a cheap wafer board or some printed circuit board that you buy or have designed. If your project requires a microcontroller, then prepare for a world of pain, because this is where things get really, really complicated. But becomes really, really exciting and very rewarding for the time you put in. Microcontrollers come in various flavors, and some are more delicious than others. Depending upon the type of chip and version you buy, determines the number of bits it can flip within a given time and what programming language they can understand right out of the factory. For example, Arduino boards have bootloaders which allow for the AVR chips to be programmed in the higher Arduino language as well as the default language of C. The higher, the worse, because the further away you go from talking to the actual hardware. Higher languages focus more on object-oriented programming, which is kind of like daydreaming concepts to get the job done, whereas a lower level language is more logical and focused on actually flipping those switches by hand. Lower languages are somewhat harder to learn but take up less space, and a language like C is more applicable to programming in general and will help if you decide to learn other useful languages like Python. Python is great. Arduino's competitor, Raspberry Pi, can be programmed in Python. Do everything the Arduino can do, and even has HDMI video output, but more on that later. You could go strictly with hardware, but you will be significantly limited to what you can create and would be missing out on some really incredible creations. When learning electronics and robotics, you can think of it as learning multiple disciplines at once, which is why companies like Arduino and Raspberry Pi have stepped in to attempt to bridge the divide between unknowledgeable hobbyists and serious enthusiasts and professionals. Whichever way you go is up to you. I recommend going deep, because the more you learn, the more powerful you become. The more powerful you become, the more freedom you will have. Seriously, did I mention you will be able to fix things? Things that cost a lot of money? You'll be able to open up electronics and understand all that junk on the board and be able to understand the increasingly complex world around you. If you want me to show you how to program these chips to make robotic and electronic programs in the C language, subscribe to this channel. Also, be sure to check out my most excellent site where you can read up on all of the material we will be covering here. See you soon.